All right, so you just finished practicing on quizzes with some different sequences. Today we're going to talk about geometric sequences. And a sequence is just a list of numbers in a particular order. And examples would be 2, 4, 6, 8, 1, 3, 9, 27. Okay, a geometric sequence is a sequence created by multiplying or dividing the previous term by a constant. We're going to call that constant K. So example, we have 2, 6, 18, 54. Well, to go from 2 to 6, I multiplied by 3. To go from 6 to 18, I multiplied by 3. From 18 to 54, I multiplied by 3. A geometric sequence is something new that we haven't talked about before. But I want to remind you about arithmetic sequences, which we talked about earlier in the year. So remember that an arithmetic sequence is like a geometric sequence, but it's created by adding or subtracting a constant K. So we have geometric and we have arithmetic sequences. Okay, a common ratio refers to geometric sequences, and that's the number that a term is multiplied by, so multiplied or divided, to get the next term in the sequence. So here, to go from 3 to 15, we multiplied 3 by 5. To go from 15 to 75, we multiplied by 5. So here, our common ratio, R, is equal to 5. Now, the difference between an arithmetic sequence and a geometric is that with an arithmetic, we're not going to have a common ratio. We have just a common difference. And that's because we're just adding or subtracting. It's important to know the difference between a geometric and arithmetic. That's all you need to know for algebra are those two sequences. As you progress in math, you will learn about other sequences. All right. When we're talking about sequences, we can either write our equations as a recursive rule or an explicit rule. The recursive rule is consider the following geometric sequence, 2, 10, 50. Let's find the fifth term. So to go from 2 to 10, we multiplied by 5. To go from 10 to 50, we multiplied by 5. So to go from 50 to our next term, we would multiply by 5. 50 times 5 is going to be 250. Then to go from 250 to our next term, we're going to multiply 250 times 5. and we're going to get 1250. And that is our fifth term because this is our first, our second, our third, our fourth, and our fifth term. Finding a term this way is called a recursive rule. It's useful for finding smaller terms in a sequence. We can summarize this rule using the formula a sub n, and a sub n just means any number in a sequence. R is our common ratio. And a sub n minus 1 is the term before. So we need to know the term before in order to find any number in the sequence. Okay, so this here is our recursive formula. And you may see a question like this on the EOC in the forms of identify the recursive formula for this sequence. So use this to write a rule for the sequence, then find the sixth term. So we're looking for the sixth term. So we're going to write a sub 6 because it's saying the sixth term. That's going to equal our common ratio, right? Because that's what our R means, is our common ratio. So that's going to be 5 multiplied by our A sub 5. And the reason, I'll even show you, I'm going to erase that 5. That's going to be 6 minus 1. So it really becomes A sub 6 because I'm looking for my sixth term is equal to 5 multiplied by our A sub 5 because 6 minus 1 is equal to 5. That would be the recursive formula for this sequence. You can also write an explicit rule. The explicit rule is much more helpful. Because this can help you find any number in a sequence. Because what if we wanted to find the 100th term? If we want to find the 100th term, there is a faster way to find larger terms, which is called the explicit rule. Because if we used the recursive, we would have to sit there and do the calculations 99 times. We don't want to do that. So we're going to use the explicit rule. So let's look at the formula below. We have A sub n is equal to A sub 1 multiplied by R times n minus R to the n minus 1 power. Okay, again, this A sub n is any number in the sequence. And so that's just going to determine on which number they're looking for. Our A sub 1 is our first number in the sequence, our first term in the sequence. So if your sequence starts with the number 1, then it would be 1. If your sequence starts with the number 3, then it would be 3. You need to know your first term in the sequence to use your explicit rule. And then again, R is our common ratio. And the n minus 1 is the number term you're looking for minus 1. So if you're looking for the 100th term, your exponent for R would be 99 because it's 100 minus 1. So use the formula to write an explicit rule for the sequence above to find the 100th term. So we're going to have a sub 100 because we're looking for the 100th term. That's going to equal a sub 1, which our first term in the sequence, look back up at that sequence, our first term was number 2. So that's going to equal 2 because that's the first number in our sequence. That's going to be multiplied by our common ratio, which is 5, to the 100th minus 1 power, which is the same thing as a sub 100 is equal to 2 times 5 to the power of 99. And that is your explicit rule for this geometric sequence. So let's see how we can apply this. So let's look at this sequence here in number 1. Is the sequence geometric or not? Well, from 2 to 4, I either added 2 or multiplied by 2, so that's not really going to help me. From 4 to 6, I didn't multiply by 2, I added 2. So now I know what happened here. So is this sequence geometric or arithmetic? It's arithmetic. So it is not, because it has a common difference and not a common ratio. In number 3, it says, what is the common ratio in the sequence? So we went from -4 to 8. Well, to go from -4 to 8, I would have had to multiply by a -2. If I go from 8 to -16, again, I had to multiply by -2. And I'm just going to put an X so you know that I'm multiplying. -16 to 32, I'm multiplying by a -2. So the common ratio, my R, is equal to -2. Number 5, find the next 3 terms in the sequence. You have 2, then 1, then 0.5, then 0.25. Well, what number can you divide by 2 and get 1? Well, if you divide 2 by 2, you're going to get 1. If you divide 1 by 2, you're going to get 0.5. If you divide 0.5 by 2, you're going to get 0.25. 0.25 divided by 2 is going to equal 0.125. When you divide that by 2, you're going to get 0.0625. And when you divide that by 2, you're going to get 0.03125. So those are the next 3 terms in the sequence. Number 7, write a recursive rule. Again, we're looking at the recursive rule for the nth term of the sequence for 816. So they didn't give us the term, so we're just going to write it as a sub n is equal to 2. How do I know it's 2? Well, to go from 4 to 8, I multiplied by 2. from 8 to 16, I multiplied by 2. So I'm going to multiply, a sub n is equal to 2, which is my ratio. And that is going to be multiplied by a sub n minus 1. Okay, because I'm just subtracting, I need to know the previous term, in order to find the next term, the nth term. Number 9. Now we're going to write an explicit rule for the nth term of the sequence 3, 6, 12. So first I need to determine my ratio. To go from 3 to 6, I multiplied by 2. 6 to 12, I multiplied by 2. So my explicit rule is going to be a sub n is equal to my common ratio. Sorry, my first term, 3. First term goes first when I'm in the explicit rule. The first term is 3. I'm going to multiply that first term times the ratio, which is 2. Multiplying by the ratio. And that's going to be raised to the nth minus 1 power. We don't know what n is yet. We're just writing the explicit formula, rule. So now they want us to find a sub 75. They want us to find the 75th term. So the 75th term, that would look like a sub 75 is equal to 3 multiplied by 2 to the 75th minus 1 power, so 74th power. And then when I plug that all into my calculator, so I'm going to do 2 to the 74th power which would be a very large number. And I'm going to use the x to the y power and type in 74. And that equals a lot of zeros. So the way that you would write that is going to be 5.67 times 10 to the 22nd power. We used scientific notation here. Okay. Don't worry, I saved the easier ones for you. That's just a really difficult example. Oops. So now what I want you to do is I want you to go do 2, 4, 6, 8, and 10 on your own. Okay, if you have questions, you can ask me in class or come to tutoring. But I just want you to try them. Put a little bit of effort in, rewatch the video if you need to, ask me questions if you need to, but I want you to try the other side of this worksheet on your own. Okay, refer back to the odd numbers that we did together and try the even ones on your own. Have a great day. Bye, guys.